This homework solutions video is for Science and Mechanics, Unit 2, Force and Gravity, Section 1, Force. Number 1. A car engine provides a driving force of 1,250 pounds. Find the acceleration of the 80-slug car with 5 passengers on board that have a mass of 5 slugs each. So the first thing that we want to do in this problem is figure out what we're trying to solve for. So we are trying to find the acceleration. So we are going to look at the formula wheel, the force, mass, acceleration formula wheel, to figure out what our equation for acceleration will be. So we have force on top, mass and acceleration on the bottom. So we're solving for acceleration, so we're going to cover that up. Acceleration is equal to the force divided by the mass. The next thing that we have to recognize in this problem is that we're told that the car has a mass of 80 slugs, and there are also 5 passengers on board that have a mass of 5 slugs each. So we need to find the total mass of the car and the people in the car, and then that will be the mass that we have to use in this problem. So the total mass is going to equal the mass of the car plus the mass of all of the people. So the car's mass is 80 slugs, and there are 5 people in this car that have a mass of 5 slugs each, so 5 times 5 is 25. So now we can take 80 plus 25, so the total mass of this car is 105 slugs. Now that we know the total mass of the car, we can substitute that into our formula for acceleration. So the 105 slugs mass goes on the bottom. Force, in this problem, the driving force we're told is 1,250 pounds. So now we can divide 1,250 divided by 105, and we get approximately 11.9 feet per second squared. Number 2. A pickup truck with a mass of 1,400 kilograms moving at 32 meters per second stops in a time of 9 seconds. What force do the brakes exert on this truck? So again, the first thing that we need to do is recognize what are we solving for. In this problem, we're trying to find the force. So again, looking at the force, mass, acceleration formula wheel, if we want to find force, that's equal to the mass times the acceleration. In this problem, however, we are not specifically told what the acceleration is. We have to find that first before we can substitute that in to solve for the force. So thinking back to Unit 1, we learned that acceleration is equal to the change in speed divided by time. So again, change in speed is final speed minus initial speed divided by time. So in this problem, the final speed, well, we're slowing down to a stop, so our final speed will be 0. Our initial speed is 32 meters per second, and then the time is 9 seconds. So this gives us an acceleration of approximately 3.56 meters per second squared. And this technically is a negative 3.56 meters per second squared, and the negative sign just tells us that we are slowing down instead of speeding up. So now that we have the acceleration figured out, now we can substitute that into our original equation that we're trying to solve. Force is equal to the mass, which we're told is 1,400 kilograms. The acceleration is 3.56 meters per second squared, and we're dropping the negative sign here because in the force equation, that will just tell us which direction the force is being applied in, and that doesn't matter to us right now. So multiplying 1,400 kilograms times 3.56 meters per second squared, we get 4,984 newtons. But again, in this class, we want to round to 3 significant digits, so we're going to round to the tens place. So this becomes 4,980 newtons.